Okay, we're going to look at D1. So D has to do with wave speed. So the one equation is V is equal to F lambda. That's our equation for practice D. So it says a piano emits frequencies that range from, so we're going to write our given. So they tell us so frequency is equal to F, so they tell us an initial frequency. So I'll just call this Fi, is 28 hertz, to a high of about 4,200 hertz. So I'm going to call that FF for the final. Find the range of wavelengths in air attained by this instrument when the speed of sound in air is about 340 meters per second. So V is equal to 340 meters per second. So I want to find lambda. So what I'm going to do is, I know my basic equation is V is equal to F lambda. And I want to find lambda. So I'm going to rearrange the equation to solve for the unknown in terms of the known. So lambda is equal to V over F. So first I'll find it for this one, and then I'll find it for this one. So I'll say for the first one, this is equal to 340 meters per second over 28 hertz. Now remember, hertz is 1 over a second. So 340 divided by 28 is 12. And before I just write in my unit, I know that I'm going to carry my units through to check my work. So a meter per second divided by 1 over a second is the same thing as a meter per second times a second over 1. So this second cancels with that, and I end up with meters. Is meters the correct unit for wavelength? Yeah, so I didn't make a mistake. Then I'm going to do the same thing with the other one. So lambda is V over F. So it's equal to 340 meters per second divided by 4,200 hertz. So this comes out to 0.0809 meters. So now when it says what's the range, well, to put it in the form that they want, the range would just be from the lowest wavelength, which would be 0.81, to 12 meters, because it's going to be anywhere in between. So that's just the way that they ask that. And that's it. So that's our one equation for today, that V is equal to F lambda.